Isn't this exciting? Our first math video of the year. It's a 9-fer. It's to reach back to your number sense with decimals and integers and fractions. So the information that you have here, all of you should know how to do this because these would have been skills that have been taught you already. These skills are going to play a vital role in your success in Chapter 2, your first chapter, in Grade 9 Math on rational numbers. We'll talk about rational numbers later, but right now we're just working on the review. Our first question gives us two fractions and says true or false. It says, is 7/10 greater than 10/12? True or false? In order to achieve this, you have to do it one of two ways. The first way, and the way that I think 96% of all people did it, was they changed both of those to decimals. So 7/10, most of you know that that is 7/10, 0.7. If you didn't know, the easiest way to change any fraction to a decimal is to take a calculator, take the numerator, which in this case is 7, and divide it by the denominator, which is 10. And when you get that, you get 0.7. The way I also like to think of it is if you look at this actual division symbol, the division symbol is a dot, a line, and a dot. And that's a great way to remember it because this dot is the numerator, and this dot is the denominator, and this little line is like your fraction line. So it helps you remember that to change a fraction to a decimal, just take the numerator and divide it by its denominator. If that's true, then 10/12, I could take that to a decimal by going numerator divided by denominator, and I get 0.83 repeating, or 0.83 repeating. And is 0.7 greater than 0.8? No. So therefore, your answer is false. And if you showed this work, you also showed why, which is important with true and false. You have to show why it's true or why it's false. Is there another way? Anyone else know another way? Jackson, what's the other way? Okay. You made equivalent fractions. So you looked at the denominators. If I could paraphrase what Jackson's saying, he looked at the denominators 10 and 12. And you very astutely realized that a common multiple of 10 and 12 is the number 60. So what I mean by that is if you took 10 and you took 12 and you looked at all the multiples, 10, 20, 30, 40, 50, 60, 70, you did 12, 24, 36, 48, 50, or sorry, 60, 72. The first one they share is this number 60, right? That's a multiple. Now, because he knew that, what he's saying is, oh, hello, he could take 7/10 and make it into an equivalent fraction out of 60, correct? Which is, how many 60ths there? 42 60ths. So 7/10 and 42 60ths are the same number, right? And I know that because if I took 42 and divided it by 60 and changed it to a decimal, that should be what? Decimal 7, right? Which it is. Right? So they are equivalent fractions. And then the same thing with 10/12. If I change it to an equivalent fraction over 60, my equivalent fraction would have been 50 60ths. So if you ask the question, is 42 60ths greater than 50 60ths? The answer is no. What would have been an easier denominator than 60? Because Jackson was thinking at a probably different numeracy level than most of you. What's an easier one that he could have used? Still makes an easier equivalent fraction. Did anyone choose a different denominator? If you did it that way? I would have chose 120, right? I would have said, instead of using those, I know that if I just multiply those two numbers together, that 120 can be used for that, and 120 can be used for that. And if I did it that way, I'd be multiplying by 12, multiplying by 12, that's 80, that's 84, multiplying by 10, that's 100. I could get the same results for comparison by making it this, right? Is 84 120th greater than or less than 120? So it's false there. So that was a different way you could do it. Jackson just did a really good one by identifying the first common multiple they share. How many would have ever thought of doing it that way? Let's reverse it. How many would have never thought of doing it that way? That's good. Okay. Most of you probably did this, but it's important that you know there are two ways to compare fractions, either as equivalent fractions with common denominators or converting them to decimals. Question 2. If you showed your work, Kaylee, if you showed your work, you knew from order of operations you do multiplication first, right? So then you probably had -2 plus, and then you probably just kept 12 because positive 12, just like that. And then adding two integers together, two negatives combined with 12 positives makes 10 positives. So your answer for that one is 10. By the way, we're all self-correcting, correct? Let's go back here. You're correcting this one. You're going to give yourself 1 point for work and 1 point for the answer false. That's 2 points for that question. Self-correct, self-give your mark. Second question, 1 point for work, 1 point for the answer. So question 2 is worth 2 points. All right? Just self-correct. It's all good. The next question gives you a mixed fraction and apparently wants you to know, can you convert a mixed fraction to an improper fraction? In order to do it, there's two different ways to do it. I'm going to show you both. This 2, if I think of the whole number 2, right, and I think about what that number means as a fraction, 2 is really 8/4, right? 8/4 makes up 2. And then this additional 3/4 means that if I think of 2 as being 8/4 and the 3/4 as being 3/4 and ask how many quarters do you have altogether, the answer here would be 11/4, right? That 2 is 8/4, the 3/4, add them together, you get 11/4. Most of us have just learned a trick, and the trick helps us get the answer, but it doesn't really help you understand the size of the numbers. And that trick goes back in the days when you took the denominator and multiplied it by 2 to get 8, right? And you know what? If you think about it, that's why that 8/4 is there. And then you added on that 3. You added on that 3, which is why this is here, giving you 11/4, right? How many did it that way, right? How many did it this way in their head? They just thought about it. There's some people that just think about it. How many didn't know what to do and just left it blank? Perfect. Thank you. Third question is integer operations. Again, here we have the multiplication first, which is designed to confuse you because you never really have that. But -2 times -3, a negative times a negative is a positive. So if I showed my work correctly, I'd do that. And then 6 positives and 4 negatives. I have more positives, therefore, my final answer is a positive 2. 1 point for work, 1 point for the answer. By the way, the last question, just 1 point for the correct answer of 11/4. I don't care how you got it, just 1 point. Next one is the addition of fractions, which is what grade? 7. In order to add fractions together, you learn through repetitive ad nauseum work that you need to find a common denominator. The first multiple to 2 and 5, just like Jackson did when he made the equivalent fractions with 60, I know that the first common multiple that 2 and 5 share the first one they share is 10, and therefore can be used as the common denominator, right? Once we have that, we realize we multiply 2 to get 10. We multiply that to get 5. So an equivalent fraction to a half with a denominator of 10 is 5/10. An equivalent fraction to 3/5 is 6/10. That's the same question, just common denominators. Once we have it, add your numerators. Most of you don't show this step right here. I like it when you do for grade 9. Most of us, 99.78% of us, will not show this step, right? You would never show adding the numerators and keeping the denominator. But it'll be very valuable in chapter 2, the next chapter we do, because we're going to be using negatives. So your answer is 11/10, or if you're highly intelligent, you reconfigured that as an improper fraction. You give 1 and 1/10. 1 point for showing this work, and 1 point for showing either answer. I don't care which one it is. They're both the same answer. 2 points for that question. Your next question is the multiplication of fractions. And from an algorithm or from a procedural standpoint, multiplying fractions, the grade 8 outcome of multiplying fractions is 10 million times easier than adding fractions, right? Because any buffoon can add or can multiply two fractions together because all I have to do is multiply your numerators and multiply your denominators, and you get final answer of 3/10, right? Piece of cake, easy peasy, lemon squeezy. A more difficult thing from grade 8 math would be, can you draw it? Does anyone remember how to draw that question? Well, if we think about it, what this question is saying, when I write it like this, if I was to think about a context I would ever multiply those two fractions, I'd have to be able to read it, interpret it, and realize what it says. And really what it says is half. The multiplication sign is always of, right? We always can think of the multiplication symbol as the word of, 3/5. So if I think about the context of that question might have been used in half of 3/5. So if that's true, if I was to draw a rectangle and shade in 3/5, would you all agree that's 3/5? We're all good on that, right? And Maddie, if I said take half of it, you'd grab your marker, you'd cut it in half, and you'd say that's my half. That's that little check mark above that line represents half of 3/5, right? But if I drew this and said, what is this picture? We'd say there's now 10 parts. There's now 10 parts. And since I get the top part, that's 3 of them. 3 parts out of the 10 there are what I get to keep. So therefore, contextually saying half of 3/5, this is really important as to why do we multiply fractions together? What is the purpose behind multiplying fractions? If you understand my picture, you understand why the answer is 3/10. If all you know is to get the answer, I multiply the tops and multiply the bottoms, you're missing that number sense part. You're missing that part of why does it work? What is the importance of it, right? How many of you remember this vaguely from the back recesses of your brain? Yeah. How many have never seen this before? Some of you. Okay. It's good to know. That's good to know. Half divided by 3/5. Algorithm, procedure. How do you divide fractions? Ben, what do you do? Right. So you learned algorithm-wise to get the answer. You learned that it's real easy. Keep the first fraction, change to multiplication, and your teacher taught you this word reciprocal, right? The flip. So if you do this, you learn that you will always get the same answer. Problem is, that's just getting the answer. That's not understanding what exactly is it I'm doing when I'm dividing those up. So you got the answer of 5/6, no problem, right? When would you ever divide that? You'd be like, oh, I have no idea. But let me give you the context I always like to think of. I always like to think of it as terms of money. Here's what I always used to say. Do you have the ability to think of those fractions as decimals? Yeah. What's a half as a decimal? 0.5. What's 3/5 as a decimal? Decimal 6. Now watch this. Here's how I always rationalize it, and it made sense to me. If I think of it as money, I have 50 cents. You with me so far? I'm dividing it into piles or groups of 60 cents. I have 50 cents. I'm dividing it into piles of 60 cents. Can I make a pile if I have 50 cents and I have to make a pile of 60 cents? No. Can I almost make a pile? So I almost can make one pile, which means I can make 5/6 of a pile. Almost one, right? To me, this context with fractions, money, makes sense. Let's try another one just for poops and giggles. Let's go with this. Let's think about it in terms of money, okay? Let's not change that to a mixed fraction, flip it. No, let's not do that. Let's think money. How much money do I have? $1.50. And I'm dividing it into piles of how big? 75 cents. Does everyone agree with that idea? If you have $1.50 and you have to make piles of 75 cents, how many piles can you make? Exactly 2, correct? So your answer should just be 2. Agreed? Does everyone agree with that? You have $1.50, you got to divide it into piles of 75 cents. How many piles can you make? 2. If we go back in time and think about it just from an algorithm standpoint, you would have done this. Well, 1.5 is 3/2 divided by 3/4. That's the same question. Keep your first fraction, change the multiplication by the reciprocal. That would be what you get. Multiply your numerators, you get 12. Multiply your denominators, you get 6. 12 over 6 is the same thing as 2. You guys remember that? Do you guys ever think of it that way? Or it's just me? I'm the only guy that thinks that way? Interesting. All right, let's just try one more. You guys do this one. Let's do this. See how well you do with it. Don't use fractions. Think money, and think of the answer using just money. Okay. So if you think about this one, this is $1.20 because a fifth of a dollar is 20 cents. If you know that, and if you didn't know it, you could have said, well, 1 1/5 is equal to 1 2/10, and 1 2/10 is the same thing as that number except an insignificant zero. Same thing. Divided into, how much is 1/10 of a dollar better known as? 10 cents, right? You have $1.20 divided into piles of 10 cents. How many piles can you make? 12. Your answer is 12, right? Not using fractions, just using common sense money ideas, thinking about it in money, you got the answer 12. Now, if I had to just work with fractions, what would I have done? I would have said, okay, this is 6/5 divided by 1/10. I'm going to change that mixed fraction to improper. Then I'm going to keep that first fraction, change the multiplication by the reciprocal, and I get that. Then I multiply my numerators, multiply my denominators. 60 over 5 is exactly 12. 60 divided by 5 is 12. Jackson. So if you had, give me another one, give me the question. 1 5/7. Okay, sure. Divided by 3/8. Okay. So for that other method, it doesn't really work real well, but let's just use it just for a second. So I don't know what 5/7 is as a decimal. I know it's more than 0.5, right? Because 3.5 out of 7 would be 0.5. So 5 out of 7 is going to be like maybe 0.7. I don't know. I could figure it out real quick by going 5 divided by 7 if I needed to. It's like 0.7, roughly, right? So it's 1.7 something. I'm just going to make it approximately that. Everyone go with that? And then 3/8, is that going to be more or less than 50 cents? We know it's less than 50 cents because 4/8 would be 50 cents. So 3/8 might be 40 cents. Okay? If I get my calculator, it's going to be 0.375. 0.375 is roughly 40 cents. Okay? So I'm still in estimation mode. I have $1.70 divided into 40 cents. How many can I make? 2 is 80 cents. 3 is $1.20. 4 is $1.60. 4 and a bit, right? So my answer is 4 and a little bit, right? 4 and a little bit. Would you agree with that? So my answer as a mixed fraction is going to be 4 and a numerator and a denominator. So 4 with a mixed fraction with 4 as the whole number, roughly. That's just estimation. So that's a good way to get, I would never, if this was the real world and I had to solve this question, I'd probably be using decimals anyway, right? But here we'd have 12/7 multiplied by the reciprocal, right? Which is 96 over 21, which is 4 and 12/21. You with me? Remember that? Just a good way to use money to estimate. Anyway, I digress. That was a 25-minute video on something we didn't need to talk about. That's okay. Order of operations. Do I do addition first or subtraction first? Benjamin has hit the nail on the head. You don't do one or the other first. You do whatever comes first in the order it appears from left to right. Not always addition first, then subtraction. It's whatever occurs first. In this case, it is addition. If I'm doing this without a calculator, I always think about money again. $1.40 plus 3.80. It makes more sense to me. That is $5.20, or 5.2. 5.2 take away 1.04. If I do it in my head, $5.20 take away $1.04 would be $4.16. So my answer is 4.16. If I had trouble with it, Put an extra 0 on there. Do it like that. How many got that right? How many used a calculator? Ah, you did. I know you did. Whatever. Question, whenever we're on here, is the same thing except multiplication this time. So it's 4 plus, what's 2.5 times 3 in your heads? Close. 7.5. Because 2.5 times 2 is 5. So times 3 is 7.5. And when you add those together, you get 11.5. Is that the last question? Perfect.